A raw instruction for a CPU, often called a machine code instruction, is just a bunch of binary digits. In fact, everything in computers is an electrical signal, represented in binary, whether it is instructions, data, program variables, part of an image, status flags, or anything else. Computer logic works on Boolean algebra that is focused on the principles of true and false. True and false equates easily to binary, which has only two possible values for each bit. It is easier for humans to use decimal to understand the results, but this made the programming of logic and the design of the machines much harder, and decimal computers were phased out quite quickly. The binary instructions are actually formed from a number of parts. The first part is the opcode, or operation code. Each processor family has an instruction set, and the programmer can look up the code for individual instructions. This is effectively what is happening when a CPU decodes an instruction. The rest of the instruction is one or more operands, bits of data that can be operated on by the operation. In this simplified example, the first nibble, 4 bits or half a byte, is the opcode 0110, which could mean add. The second and third nibbles are 2 operands, binary integers 1001 and 0010. So this means add 9 and add 2. As there is no destination specified, the result would probably be put in the accumulator. But if these opcodes are binary data, how do we add registers or memory addresses? This is where addressing modes come in. The addressing mode tells us how to interpret the operands. Some CPUs have completely different instructions for each addressing mode. Or some will have part of the opcode, maybe the last few bits, to indicate the addressing mode to be used. Having fewer instructions may be simpler for the programmer, but may be inefficient in the use of bits for the overall instruction. If 3 bits are used for the memory addressing modes, for example, then there are 8 possible addressing modes that can be represented through 000 to 111. If there are less than 8, but more than 4 modes, then 1 bit is being kept available for possibly very infrequent use. Each CPU family has different addressing modes, but we will just touch on some of the most commonly referred to. Intermediate addressing just provides the data itself as the operands, just like we did earlier. Direct and indirect addressing instead provide a memory location in the operand. Direct addressing has addresses in the operands. These addresses tell the CPU where to get the data it needs, which could be another memory location, or a CPU register, or even an external device. There may be different types of direct addressing for memory and registers. In indirect addressing, the operands hold an address, which in turn holds the address of the data to be fetched and used as part of the program.